everyone, and welcome back to another episode of Oceanus. Anchoring an aircraft carrier is similar to anchoring a traditional ship when it's in the harbor. The huge block of iron and steel chain is released on the ocean floor, but the scenario changes when the aircraft carrier is in the middle of the ocean. A traditional ship does not require anchoring here. Then why anchors are crucial on aircraft carriers even when they are operating in the open sea? These massive vessels play a vital role in projecting power across the seas, and anchors are integral to their safe and effective operations. To carry out the Navy's mission effectively, these massive vessels need to stay stationary during key operations, like takeoffs and landing of aircraft. Anchors allow carriers to maintain their position effectively. Without the ability to anchor, the carrier would drift aimlessly due to the force of winds, currents, and waves. Anchors are also vital for anchoring the carrier in port and during maintenance. But how are these anchors managed with such precision? That's where automation comes into play. Let's take a closer look at the different components of an anchor system on a U.S. Navy aircraft carrier. Modern anchor systems are designed to be robust and efficient, combining traditional mechanical elements with advanced automation technologies. You have the anchor itself, the chain, the windlass, and the control systems. The chain length for the anchor on the biggest U.S. Navy aircraft carrier, Gerald R. Ford, is 1,440 feet, or 439 meters long, and weighs about 30,000 pounds. The anchor is attached to a massive chain, and this chain is stored in a chain locker deep within the ship. The windlass is a powerful winch, which is responsible for hoisting and lowering the anchor and chain. It can also apply brakes to the anchor chain when its desired length is achieved. But the automation system is where the magic happens. It makes this entire process seamless. Sensors scattered throughout the ship constantly gather data. Everything from the carrier's position to the current sea state. These sensors provide real-time information to the ship's advanced computer systems, which are the brains behind the automation magic. This computational marvel that calculates the optimal amount of chain required to anchor the carrier safely and securely. Once the calculated chain length is determined, the automation system takes control of the windlass, that powerful winch responsible for hoisting and lowering the anchor. The windlass, guided by precise control algorithms, starts letting out the chain at the perfect rate, ensuring that the carrier remains steady during the process. As the anchor reaches its desired depth, sensors continue to monitor the chain tension and the carrier's position. If any deviations are detected, the automation system makes real-time adjustments to the chain length, fine-tuning it to maintain the carrier's position within inches.
When you do the anchor drop test, it's to make sure there's no deficiencies wrong with the anchor. So you drop it, lower it in the water with the wildcats engaged, and then after you test that, you bring it back up, and then you disengage it, you free fall it, stop it, so you set the brake, and it's got a certain amount of play it can give, and then you do it again to a different depth, which would be 30 fathoms. And after that, we bring the anchor back up.
The anchors play an incredible role during the high-intensity launching and recovery operations on a U.S. Navy aircraft carrier. The takeoff and landing operations are crucial times on the carrier, and anchors are a key part of maintaining the carrier's stability and position during these movements of aircraft. Imagine the deck of an aircraft carrier, which is a confined space, where aircraft accelerate to take off or decelerate upon landing. The forces generated during these operations can be immense. Here's where the anchor system shines in its automation prowess. During takeoff, fighter jets and other aircraft rely on powerful catapults to achieve the necessary speed for flight. These catapults produce tremendous thrust, propelling the aircraft forward with incredible force. At the same time, arresting cables on the deck engage with landing aircraft, rapidly decelerating them from high speeds to a controlled stop. All of this activity can cause the carrier to experience shifts in position and movement. The anchor system comes into play to counteract these forces. The ship's automation systems are constantly monitoring the carrier's position, the aircraft movements, and the sea conditions. As an aircraft takes off or lands, the automation algorithms work in real time to adjust the tension on the anchor chain. The goal is to keep the carrier as steady as possible. If an aircraft is launching, the anchor system may increase the tension on the anchor chain, creating a counter force that helps resist the forward thrust of the aircraft and maintain the carrier's position. On the other hand, during aircraft recovery, the automation might slightly reduce the tension to offset the deceleration forces acting on the ship. It's like a delicate balancing act that requires split-second calculations and adjustments. So next time you watch a video of aircraft taking off or landing on an aircraft carrier, remember that behind the scenes, a highly sophisticated automation system is at play. It's the unsung hero that contributes to the safety and success of these intricate operations, allowing naval aviation to push the boundaries of what's possible. Of course, safety is a paramount concern in naval operations. The automation systems are designed with failures in mind. Backup sensors, redundant control systems, and fail-safe mechanisms ensure that even in the rare event of a failure, the carrier's anchor operations can continue without compromising safety. Anchors used on U.S. Navy aircraft carriers are powered by cutting-edge automation technologies. The seamless coordination of sensors, algorithms, and control systems allow these massive vessels to navigate and operate with unparalleled precision. That's it. If you've enjoyed this video, please make sure to subscribe to the channel for more videos on ships and other maritime topics. See you in the next one.